Okay, thanks very much, and thank you for the organizers to have this beautiful conference. And I know that the cameras are switched off, but I really like to talk seeing people. So if you don't mind, you can switch on your camera so I can see if people are still bored, or I should talk faster or talk about something completely different things. Hi everyone. Okay, that's much better. Uh, so today I'd like to talk about a software that is built to, oops, sorry, something weird is going on my computer. Okay, so I'd like to talk about a software that was mainly developed with researchers and research in mind, but we found out that it's pretty useful for educational purposes as well. And the main idea, you can see my mouse and everything, right? When I shared with the screen. So the main idea is to build a software that runs the analysis automatically and optimizes the output. And today I'd like to talk about these three things. I'd like to introduce this software very briefly and explain how this could be used in statistical education, why it could be a better choice compared to more widespread software packages, and a few observations about the efficiency of this software. And if you don't have too many questions, and we'll still have time, I will give you a few specific details how this software handles data and the results differently compared to other software packages. So there are two key features in this software that differentiates it from other packages. And the first one, it is the automatic analysis. And it's automatic in a sense that you don't have to tell that you want to run a t-test or a Friedman test and so on. You just have to tell it, okay, this is my dependent variable, this is my grouping variable. So practically you're providing a professional question, not statistical question, and everything will be automatically compiled and analyzed. And this makes the analysis much faster. And another key point is that we want to optimize the output to be more understandable. So that in a lot of software packages there are a lot of tables explaining a lot of details, and no one knows what they are. I know some of my colleagues teaching statistics, they're so confused that sometimes they are teaching the wrong table. So we try to make the output concise and easy to understand, and so we try to carefully design how the output looks like. And it is free and open source. You can download it. And also from an educational viewpoint, it's important that it's localized to many languages, at least partially. It is localized to 3 languages, maybe. So let me just show you how it works, and just to give you a impression. And so this is how the software looks like. It's pretty kind of minimal. So here you will see the data, and here this is the results pane, and the menu is pretty simple. I still hope that you can see even if those letters are a bit small. Okay, so we have a data menu where we can import the data. That's the main function, and also we can filter outliers. And the main point is the analysis menu. Here everything is gray because we haven't loaded any data yet. But you can see that instead of seeing specific hypothesis tests, whatever, you can see kind of real research questions like explore relation of variable pair, or compare groups, or inter-rater reliability analysis, and so on. And everything behind that will be, all the analysis will be compiled automatically. And we have a simple results menu where you can handle this results pane. And also finally, we have a Cogstat menu where software specific functions are available. Okay, so let's just open some data, and we have quite a lot of demo data packaged with this software. And these will be familiar for you. There are quite a lot of popular textbooks and other materials that are packaged here, where the license allowed us to do that. And for example, we have this learning statistics with Cogstat. This is a textbook. This is a modification or rework of Daniel Navarro's book, Learning Statistics with R. And we have this Cogstat version. So let me just load data. And I'd like to highlight that there are a lot of data formats that you can use. So even if you decide to try Cogstat, you don't have to transform your data in new data format. You can use your previous data files. So I opened the data, and this is a simple one. On the results pane, you can see a short description of the loaded data in case you would want to save it later. And in the analysis menu, let's just try compare groups, or let's choose compare groups. The dialogue is really similar to the usual dialogues you can see in the software. Maybe the only difference is that it's a bit more minimal. So we want to handle everything behind the scene, and the user usually should set only minimal set of options. So here we are choosing the dependent and grouping variable. So grade will be a dependent variable here, and tutor will be the grouping variable. I hit OK, and this is how it looks like. So we have quite a general structure how the results are organized. So first, obviously, you can see what data we are analyzing and how many observed and missing cases you have. And another, well, maybe on one hand, this sounds trivial, but on the other hand, this is really essential, that we always show the raw data first. And in many cases, when people are analyzing data, they just skip this part, and the analysis is just blind, and they are lazy to create some charts, and sometimes they misinterpret their results. So this is really essential, and it's a very simple thing, but it's fundamental. And here we can see the two tutors and their grades. Just looking at it, maybe you have the impression probably this will be significant. But the main point here is that if you have any unexpected pattern in the data, the user should see that, and you can build up your expectation what results you will have based on the raw data. Then we have another block of results called sample properties. Now, for statisticians, this is descriptive statistics. And in Cogstat, we strictly separate descriptive statistics and inferential statistics. And we are not using those terms. Those are intimidating, but we are using sample properties and population properties. And the main reason for that is that sample data, descriptive statistics is a kind of a hard fact. These are the data you have collected, what you have, and it's unquestionable that these are the things you have. On the other hand, inferential statistics is always kind of estimation, or if I want to use some stronger word, is speculation. And you can never trust it. Most probably it is true what you can see in the inferential statistics parts, but you always must have some doubt that maybe you have some specific data, or your sampling procedure was unlucky, and you will see something in the inferential statistics which is actually not true, which doesn't faithfully reflect the population parameters. So I really want to separate the inferential statistics and the descriptive statistics, because we need kind of different attitude towards those different types of information. And here in the sample properties, you can see some quite trivial things like mean and maximum, stuff like that. and standardized effect sizes and some charts here. You can see a box plot. And in the population properties, you can see two blocks. First one is population parameter estimations with point estimations and interval estimations. And then you can see the hypothesis test. And you can see that the assumptions have been checked automatically, and depending on them, the appropriate hypothesis test was run to compare the means of those two groups. Okay, so basically the point is, again, that everything is kind of automatically. You're just specifying the task, but not the specific analyses. And we are trying to build up an output that is easy to understand, or at least it's easier to understand compared to some other packages. And I will give you a few examples what other tricks we have here. Now, one important question, if you would want to, sorry, okay, an important question if you want to understand how these automatic analysis pipelines are compiled, how will we set this up? And we have quite a few simple rules here. The first one is that this is our starting point. We're just taking the usual textbooks and what they suggest, and hopefully we'll not make mistakes by following them. And another idea is that we are having inspiration from methodological literature, and I know that many of you could tell a few examples where textbooks maybe are not propagating the best practices, and we'll have quite a lot of talks about topics like that today as well. And in those cases, we are just dropping the procedure that is proposed by textbooks, and we are using some smarter solution. So here's one thing for outlier filtering. A lot of people are using mean and standard deviation, and based on that, they are trying to specify the outliers, which may not be optimal solution, and we'll have a talk about that later today. And here we are using the median absolute deviation based outlier filtering. And then there are some cases where it's really impossible to decide about some procedures, like for example, if you're using a outlier filtering, for any kind of outlier filtering, you have to specify a threshold. And clearly there is no objectively right threshold to specify, and it will always be arbitrary. And for this reason, we are just picking any of them. And one viewpoint here is to use a threshold, for example, or any other parameter, whatever, that is quite common in the literature. So maybe we can compare our results with other results in the literature. And there are some extras that we came up with, like in our charts, the axis, the line style of the axis reflects the measurement level of the variable. So if we are displaying an interval variable, then the solid line will be used. For ordinal variables, dashed lines will be used. For nominal variables, dotted lines will be used. Just to highlight, also on the charts, what kind of variables and what kind of information we are dealing with. All right, and to summarize a few key features why it's better to run analyses with Cogstat, or not specifically Cogstat, any kind of automatic analysis. This would be true for any kind of automatic analysis. On the other hand, I think Cogstat is the only software that does that. But my point is that these advantages could apply for any kind of automatic analysis if there were any other. So first of all, it's faster. You don't have to click on in a lot of menus, but the most typical stuffs will be compiled automatically. And it is more precise in the sense that, honestly, let me just give you one example. a lot of people are not checking assumptions for a lot of hypothesis tests. I didn't do that before Cogstat. And also, that's a position that could be defended, because there are some arguments that some of the assumptions for some of the hypothesis tests are not essential, or if we could see that assumptions are justified in a lot of previous cases with the same paradigm, then probably it's still satisfied for the next analysis as well. And there are a lot of other arguments, but basically there could be a lot of imprecision when people are skipping some essential problem. Or also, I mentioned that it's essential to check the raw data. And this is another example, just providing the raw data, which is cheap to check because you don't have to click for yourself to check the raw data. It will lead to more precise, not just analysis, but also interpretation. And similar to this previous point, you can have better insight about the data. And from the viewpoint of education, you don't have to spend so much time with technical details. So when you're teaching a software, there are a lot of options and a lot of other stuffs, and it requires quite some time to explain them to the students. And let me just give you a few viewpoints how this could be used in education. So referring to my previous point, it's much easier to explain students to how to use this software. So I'm a psychologist, and I also taught statistics, and I used like SPSS, GEMOV, Cogstat in my classes. And definitely, it is much easier to explain how to use Cogstat than explaining SPSS, for example. Well, SPSS could be, at least a few years back, it was still a very popular software, and still ergonomically, it's not an ideal solution, but it's still okay. But you need a lot of technical knowledge there. And after a few short explanations about how the data are handled and what is the general structure of the analysis, students can use that very quickly, and they can use that efficiently. So basically, we are spending much less time with technical details teaching the software, but we can focus on the conceptual part of the statistical knowledge. And here's another example. We are spending a lot of time in stat courses to explain how an appropriate hypothesis test should be chosen, depending on the number of groups, conditions, whatever, and assumptions, and checking them, and if they are violated, what should be done, and so on. And usually we have nice tables or flow charts or whatever, and we are teaching the students how to read these and how to choose the appropriate, for example, hypothesis test in a specific software. Now here with Cogstat, you don't have to do that. You just have to explain the general idea. Depending on the number of groups, whatever, you are choosing different hypothesis tests, and you don't have to know them by heart, because the general idea in all hypothesis tests that at the end of the day you will have a p-value, and you don't really have to understand what's going on in terms of formulas or something like that. You just have to understand that the null hypothesis and then your p-value, what they mean. And so you can save a lot of time with this, not explaining all the possible decision tree part, but you're just explaining the general idea, and you will have more time for more conceptual details.
Just give you a 5-minute warning, Attila.
Okay, thank you. And And another feature is that the output is optimized with a lot of tricks. Let me just give you one example here. So the charts should show what the numerical procedure sees. So for example, if we have two ordinal variables and we want to see the correlation between them, and we are calculating the Spearman correlation, then Spearman correlation is really a Pearson correlation, but instead of using the original values, the order of the values will be used. So if you display your original data in a scatter plot, not using the original values, but the order of those cases, and you're displaying a regular linear regression, then that is what the Spearman correlation sees. So it's a simple trick, but it makes it more intuitive to see the chart that the numerical calculation sees. Okay, and we have quite a few stuffs like that in Cogstat. And let me just skip this and turn to the third part, and I will give you some time to ask questions about the software or the general idea. That we have a lot of feedback from students, and most of them are really positive. You can see a few quotes here like, why haven't we learned this before? These are students who have learned, like, I don't know, SPSS probably before, or I wouldn't use any other software in the future, because they can see that, how easily they can find what they need here. Or this is a quote for a boy who wasn't really confident in his knowledge, and he said that, okay, I knew that Cogstat was my only chance for the exam, otherwise he knew that with SPSS he would fail, and so on. And overall, it is very positive, although they miss some features, and this is a work in progress, so there are a lot of analysis that is not present yet. Overall, most of the analysis that we are teaching in BA statistics, for psychologists at least, most of them are already included in the software. And also we have a lot of feedback from teachers. Some of the teachers I talked with or we got feedback from were not teaching psychology students, but for example, special education or sports science. And these areas are really important because they don't have as many classes on statistics as psychology students, so they have much limited statistical knowledge, and still they found that with Cogstat it's much easier to explain the fundamental bases, and students can run appropriate and precise analysis much better compared to other software. And we are also running an empirical study. This is really present time, so we will do today some measurements as well. So we want psychology students to do some statistical tasks like in a stats BA stats 101 statistics course, and we are measuring how many tasks they can solve in an hour and how precise they are and so on. And we have 3 groups using different software, and we only have preliminary results, and Cogstat seems to be the best one. And we are quite neutral in a sense that sometimes correct solution could be kind of debated, whether you really need to check the assumptions or not, or whether you have to report some component or not. So basically, we'll ask colleagues to evaluate the responses of the students to make sure that we are not using the viewpoints that Cogstat is optimized for, and those colleagues will not know what software the students used to solve the task. But basically, our preliminary results confirm the idea, and also they confirm that, for example, Jamovi is beautifully optimized for a few ergonomic details, and it pays off. So students can use that more efficiently compared to SPSS. That's what we can see in this measurement. And that's it. So this is the fourth one, which is optional. And if you don't have questions or comments, then I will go on with some other details. But I will stop here, and I'm waiting for your questions if you have.
Yeah, thank you, Attila. Yeah, little virtual round of applause from people. So we've got, well, about 3 minutes, so we're probably not going to have time for the last section. So if anyone has any questions in the chat, I'm happy to read them out. If you want to put your hand up and ask it verbally, do feel free.